Okay, we're looking at laws of exponents, lesson N7-1. We've got 5 laws of exponents given to you right here at the top. These should be all review. I'm going to number them just so that later on I might say, all right, this is like, law 1, law 2. So first one, when we have the same bases, we add the exponents. B to the m times b to the n is b to the n plus n. Second one goes hand in hand. When we divide with the same base, we subtract the exponents. Law number 3, when we raise a power to a power, b to the m to the nth power, we multiply those exponents, m times n. The fourth one, b to the negative m is equal to 1 over b to the n power. We take the reciprocal and we make it into a positive exponent. And lastly, b to the 0 is equal to 1. Anything to the 0 power is equal to 1 except for 0 itself. Okay? So, jumping into 1 through 6 here, we're evaluating without a calculator. So, negative 1 to the 12th power. This means negative 1 multiplied by itself 12 times, right? I'm not going to write all those out, but assume that I did. Okay, I have 12 negative 1s lined up here. I know that if I multiply the 1s together, I get 1. And if I have 12 negatives, an even number of negatives is going to give me a positive because each pair of negatives cancels out. So this will be a positive 1. Okay? Notice the difference between number 1 and number 2. For number 2, we have negative 3 to the 4th power, but no parentheses. Here, we're saying negative 1 in parentheses to the 12th power. That's negative 1 times itself 12 times. Here, without parentheses, this means 3 to the 4th power, 3 times 3 times 3 times 3, and then once we've done that, we're going to take the negative of it. And so that's a big difference here. 3 times 3 is 9, another 3 times 3 is 9, 9 times 9 is 81, and so my answer here is negative 81. Even though it's an even power, I get a negative answer because that does not have parentheses. If it had been negative 3 in parentheses to the 4th power, that would be a positive 81. But this is what we're looking for here, negative 81. All right? Okay, 2/3 to the negative 3 power on number 3 here. The negative power from law number 4 tells me to take the reciprocal. So I'm going to take the reciprocal. I'm going to say this is 3 over 2. And I'm going to change that into a positive 3 power. All right? The negative simply says flip it. Take the reciprocal. 3 over 2 to the positive 3. And now I'm going to do 3 to the 3rd power over 2 to the 3rd power. 3 to the 3rd is 27. 2 to the 3rd is 8. My answer is 27 over 8. I'm not going to spend much time on number 4. That goes with law number 5. Anything to the 0 power is 1, including 5. 5 to the 0 power is 1. Number 5. I have an understood 1 here with this first 5. 5 times 5 squared. All right, we have the same base. We add the exponents, and so this is 5 to the 3rd power. It is not 25 to the 3rd power. It is not 25 to the 2nd power. It is simply 5. The base stays the same. We add the exponents, 5 to the 3rd power, and 5 times 5 times 5 is 125. Okay, number 6 is going to take a little work. For number 6, what I'm going to do is I'm going to put all of these in terms of 2. So I know that 8, for instance, is 2 to the 3rd power. And then 8 is being raised to the 3rd power, so I have 2 to the 3rd raised to the 3rd. Times. I know that 64 is 2 to the 6th power. And that is being raised to the negative 1, 64 to the negative 1. And then all of that over 16, which is 2 to the 4th power, squared. So I was able to recognize right off the bat that all of these are powers of 2. And that's going to make this job a whole lot easier without a calculator. All right? So I'm raising a power to a power 3 times here. This is law number 3. And so I'm going to multiply my exponents. 3 times 3 is 9, 2 to the 9th, times 6 times negative 1 is negative 6, 2 to the negative 6, over 4 times 2 is 8, 2 to the 8th power. On top, I'm multiplying with the same base. I add those exponents. 9 plus a negative 6 is 3. So I've got 2 to the third over 2 to the 8. Okay? And so here I can subtract. I'm dividing. I can subtract those exponents. 3 minus 8 is negative 5. 2 to the negative 5, which is equal to, by law number 5, 1 over 2 to the 5th, which is 1 over 32. 2 to the 5th is 32. So all that nasty thing that we start with is just 1/32. Okay? Okay, now we're adding in variables. Starting with number 7, we're adding in variables. We're trying to simplify things with variables. We're still using those laws of exponents. So for number 7, I'm going to start by multiplying my numbers. 3 times 4. I know 3 times 4 is 12. And then I've got a times a cubed. If I don't have an exponent on it, it's always understood that it's to the first power. So a times a cubed, they have the same base. I add the exponents. 1 plus 3 is 4. I get 12a to the 4th. And I don't have to write that with a dot in between. I'm just going to write it as 12a to the 4th. Well, that was pretty straightforward. This one, a little bit trickier. Number 8, 27a cubed b cubed c to the 5th over 45a to the 4th c squared. Right? So I'm going to start with my numbers. 27 over 45. Both of those divide by 9. And so that's going to reduce. If I divide by 9, I get 3 on top. 45 divided by 9, I get 5 on the bottom. Okay? With my a's, I've got a to the 3rd over a to the 4th. So let's write that out. I'm going to say a times a times a, just to show you a little trick here. And then 4 a's on the bottom, a to the 4th on the bottom. So what's going to happen is I'm just going to cancel out common factors. So I've got 3 a's on top that are going to cancel out with 3 a's on the bottom. And so I end up with an a to the 1st on the bottom. So what really is going on here, I've got a to the 3rd over a to the 4th. If I subtract 4 minus 3, I have 1 that's not going to cancel. And since the larger number of a's is in the denominator on the bottom of the fraction, that's where that leftover a is going to go. With my b's, I only have b to the 3rd on top. So b to the 3rd is going to stay on top. So look at the c's here. I've got c to the 5th over c squared. So the 2 c's on the bottom will cancel out 2 of these 5 c's on top. 5 minus 2 is 3. I'm going to have c to the 3rd left over, and it's going to go on the top of the fraction because that's where the larger number of c's was to begin with. So my final answer, 3 b to the 3rd, c to the 3rd on the top of the fraction over 5a to the 1st on the bottom of the fraction, 3b cubed, c cubed over 5a. All right, number 9, not too bad, negative 3xy squared to the 3rd power. So this means we're multiplying negative 3xy squared times negative 3xy squared times negative 3xy squared. We're going to multiply it times itself 3 times. But what's really happening then is negative 3 is going to get multiplied times itself 3 times. X is going to get multiplied times itself 3 times. And y squared is going to get multiplied times itself 3 times. So it's not the distributive property, but it's kind of similar in that each thing is going to get that 3 outside the parentheses. Negative 3 to the 3rd, x to the 3rd, y squared to the 3rd. So let's simplify that. Negative 3 to the 3rd, negative 3 times negative 3 is 9, times another negative 3 is negative 27. X to the 1st raised to the 3rd power, 1 times 3, we multiply the exponents as x to the 3rd. And then again, we multiply the exponents, y squared to the 3rd, 2 times 3 is 6. My final answer, negative 27, x to the 3rd, y to the 6th. For number 10, I have the same base. I'm going to add the exponents. A to the x plus 3 plus x minus 3. I'm going to add now. I want to gather like terms. So I've got a. When I add x plus x, I get 2x. And then I have a plus 3 and a minus 3, which are just going to cancel out. My final answer there is a to the 2x. So those were pretty straightforward, pretty easy. All right, number 11, a little trickier. Let me show you a way to do this. This is a little trick. This will make your life easier when you're dealing with negative exponents. Here's the deal. If I take a negative exponent and I move it to the other side of the fraction, if it's in the numerator, if I move it to the denominator, that negative exponent is going to become a positive. So for example, this z to the negative 1 right here, if I move it to the bottom of the fraction, it's going to become z to the positive 1. So I'll have z to the first power, positive 1 power, on the bottom. So the y's are okay. Y to the third, it has a positive exponent. Y squared, it has a positive exponent. We'll deal with simplifying that in just a minute. Notice the x's both have negative exponents. So I'm going to take this x to the negative 2 and move it to the bottom. And that's going to be x squared on the bottom, positive 2 on the bottom. And then this x to the negative 3, we'll move it to the top, and it will become x to the positive 3 on the top. And now I don't have to think about those negative exponents. I'm just going to simplify this. So x cubed over x squared, those two x's on the bottom are going to cancel out two of the x's on top, and I'll have one x left over, and it will be in the numerator because that's where most of my x's are. Same thing's going to happen with the y's. Y to the third over y squared. The two y's on the bottom are going to cancel out two of those y's on top, and I'll have y to the first power on top because that's where most of the y's are. And then this z, that's just left over. There's nothing else to do with it but leave it where it is in the denominator. And so our final answer is xy over z. We got 3y to the negative 3 times 2x to the negative 2 plus xy plus y squared. Okay, I'm going to distribute this 3y to the negative 3 times each of the terms, the three terms inside the parentheses. When I do that, I'm going to be real explicit here, 3y to the negative 3 times 2x to the negative 2 plus 3y to the negative 3 times xy plus 3y to the negative 3 times y squared. All right. Now, multiplying this, simplifying this a little bit, I've got 6. And notice the x and the y both have negative exponents, so I'm going to bring those down to the bottom. I'm going to say this becomes a positive 2, x positive 2 squared, so x squared, and then y to the positive 3. Plus, I've got 3xy on top over y to the third on the bottom. Plus, I've got 3y squared on top over y to the third on the bottom. And I moved those y to the thirds to the bottom because they had negative exponents. Normally at this point I could simplify these last two fractions because I've got a y, I've got y's on top and y's on the bottom, but I know that what I want to end up with is common denominators. And here is my common denominator, x squared y to the third. It has to have the largest exponent on any of them, which is 3 for the y, and then I need x squared. So my common denominator here is x squared y to the third. So this first fraction's fine. I've got the 6, it's not going to change. For the y to the third here, I need to have that x squared, so I'm going to multiply top and bottom times x squared. So when I do x squared times 3xy, x times x squared, x to the first, we add the exponents, 3x to the third y over x squared y third. And same thing here, I'm missing my x squared, so I'm going to multiply times x squared over x squared. I've got x squared y to the third on the bottom. And on top, I've got 3, and there's no x's to combine with, so I'm just going to stick that x squared between my 3 and the y squared, so plus 3x squared y squared. Notice on the top, I don't have any like terms to combine, so that is fine as far as that goes. That's in good shape. Okay?